Hi everyone, my name is Benjamin, and in this video we are going to cover how we can turn our token swapper, which we built in the previous video, into a simple trading bot, and how we can run that bot on a VPS to get you started building on Solana. So we are going to talk about virtual private servers and how to set one up properly and securely, how to turn our token swapper into a simple trading bot, and finally run that trading bot on our own Solana Vibe Station VPS. And on top of that, all the code will be available for download via our GitHub repository. Now this video is part of a series, so make sure to subscribe so you can check out all the other great content. And with that said, let's get started. Alright, so let's talk VPS first. So VPS stands for Virtual Private Server, and it is a machine that hosts all your software and data needed to run your applications. This includes websites, but in our case also trading bot applications. It's called virtual because it only consumes a part of the underlying physical hardware. Now, managing physical hardware and servers can be complex and also expensive. Now, to solve that, we here at Solana Vibe Station will take care of that and allow you to consume these resources. Now, with our VPS hosting, you will receive a virtual machine that is ready to deploy and set up your applications. Now, via the SVS cloud platform, you can order a VPS which is highly optimized and designed to give you the best possible experience to interact with our RPC services. All our cloud services are hosted on our own hardware and strategically co-located within the same data center hosting our other RPC infrastructure. Additionally, we have dedicated physical cross connections between cabinets hosting our cloud infrastructure services and our Solana RPC services. This translates in ultra-fast, low-latency interactions with all our other Solana services. Alright, so let's order a VPS, check out the different options, then we will update our code to turn our token swapper into a trading bot, deploy it and configure it on our VPS, and make sure that it runs smoothly. Alright, so in order to purchase a VPS, you can go to cloud.solanavibestation.com, and then once logged in, you can click on Place New Order. After that, you can select Cloud Services, and here you can choose if you want to use a general VPS or a high-performance computing VPS. Now, the key difference between a general VPS and an HPC VPS lies in the hardware configuration, the workload optimization, and also the performance priorities. So there is optimized workload configurations, there is more memory and more bandwidth, higher IOPS to provide high-speed networking, and of course there is a better CPU architecture. Now the general VPS will do just fine for our application, but it won't tap into the full power of the hardware. And if you choose for HPC, these are really fine-tuned to fully exploit the hardware and the architecture for maximum performance in high demanding tasks. Of course, you can also compare both these two. So if you click on it under general VPS, you will see the different tiers. And of course, the tiers, they differ in the amount of resources that they will provide to you. You will get, for example, more CPUs, more memory, more storage, higher vPort speeds and bandwidth. And that is where the tiers are different. Now, if you look at, for example, the HPC VPS, also here there is different tiers that will provide you more resources, but you will have more vPort speed, for example, higher bandwidth, all these things provided within the high performance computing VPS. For this video, for the purpose of our demo, we will use a general VPS. So once you have selected your VPS, you can provide a host name, and then for today we will use SVS Token Trader. We can choose a operating system. We will go with Ubuntu server, and then you will have to provide an SSH key, and I will come back in a minute on how you can create these SSH keys that you will have to provide here. And you can also have add-ons like the Shred Stream Forwarder, but that is outside of the scope of this video. Now, once you're happy with your selection and you provided all the information, you can add some promotional codes if you have them and then click order. Now, once your order is completed successful, you will find your VPS under Services, Cloud Services, General VPS, or the VPS that you ordered. And then you can click on the VPS, and then you will see all the details related to your VPS. Alright, so while we were ordering our VPS, we had to provide an SSH key. Now, SSH stands for Secure Shell, and it is a network protocol that is used for communication between computers. However, it is often used for remote login and command execution. Now, what we will have to do is create a SSH key pair, and we will have to take the public key and provide it here while setting up the machine. A SSH key pair you can compare with a padlock. So you buy a padlock and then we give that padlock to SVS and we take the key and we will take care of that key. We will not share the key with anyone. And then they can hang it on the server. And then once we want to access that server, we can use our key to unlock that server. That's how you can look at an SSH key pair. Of course, it's not a physical padlock, but we will have a private key and a public key. And that private key that we keep in our computer, or we keep that to ourselves, we don't share that. And that public key that we will provide to SVS when setting up the machine. Then they will add that to the machine, and then when we try to log in using our private key, the actual physical key, then they will see that these two match, that it is actually a valid key pair, and then they will allow us to remotely log in into that server. Now, in order to create an SSH key pair, what you can do is start PowerShell. And this is similar on macOS or Linux. Now, once you opened PowerShell, you can go to your SSH folder, and that is often located under your users directory. Now, once you're in that SSH folder, what you can do is list the contents. And if there are no contents, that means you don't have an SSH key pair yet. So what we can do to create a new key pair is type SSH-keygen, like this. And that will ask you what the name of that key pair should be. And if you don't have any key pair, you can just enter nothing. It will take a default name. And then you will have to enter a passphrase. Now you can leave this empty, but I suggest you have a short passphrase. Now every time you will connect to that remote server, you will have to enter this passphrase. So let's just set something small. Then we have to repeat it. And once we've done that, you will see that now this key pair is created. Now, if we once again list the contents of this folder, you will see that we now have two files, and one ends with pub. So the first one is our private key, and the second one is our pub key. So if you already had a key pair, then you will see something similar. And what you can do is output the contents of this pub file. So how you can do that is by typing cat, and then you type the name of the file. And you need to make sure that you take the actual pub file and not the other one, because the other one is your private key. Now, once you do that, it will output a string. And what you can do is just copy this string and then paste it within the actual field here once creating the machine. And then that public key will be added on the machine once the machine is set up. So once you have this key pair within your SSH folder, the next time, if you want to remote login into that server, it will recognize that key pair and allow you. Of course, it will prompt you for that passphrase that you have set, but once you have entered that passphrase, you will be allowed to remote login into that server. Now, one more thing you need to make sure you do once your machine is ready is to allow remote logins via SSH to your VPS. And that you can do here within the settings of your VPS. So what you do is go to firewall, and under firewall you will see that there are no existing rules. And that is because once a VPS is created, it is completely closed off. There are no in or outbound rules. And what we will have to do is to create a rule to allow these SSH connections. And that you can do by clicking on the add new rule. And what you'll have to do here is select SSH. And here you will have to provide your source IP. And your source IP in this case is your public IP. You probably can leave this empty as well, but for security purposes, we want to only allow us to remotely log in into that machine. And that's why we specify here our public IP. The destination you can leave as is, and you just have to select SSH here. And then you click submit. And now you created an inbound rule that can be used to allow these SSH connections into your server. And we only specified the source IP as our public IP, which will only allow us to remotely log in. Now, with your SSH key created, the public key added to the machine once it was created, and the firewall rule set up, you are now ready to remotely log in into your machine. Now, to do that, we can open PowerShell once again, and I still have the same session open here. So what I can do is clear my terminal, and the next thing that we can do is SSH. And then we will have to provide the username and the actual IP of our server. So what we can do is go back to overview. So we can copy this IP, and our username at this moment is vibes. So the next thing we will type is vibes at and then that IP. And this means that we will SSH using the vibes username at the remote location, which is in this case our server. And if you press enter, then you will see that we will be prompted for that passphrase that we set up. And if we enter that passphrase, then you will see that we are now connected to our VPS. So with that all in place, we are now ready to move forward, where we will update our token swapper code, turn it into a simple trading bot, and then we will deploy our trading bot on this VPS, make sure that it runs smoothly, and then we will verify if we can buy tokens, sell tokens, and all that great stuff. Alright, so before I go over all the changes that I implemented based on the token swapper that we created in the previous videos, I want to just remind you that all the code will be available within our GitHub repository. Now in the token swapper, what we could do is add a token, and then when we clicked the add token button, that would go and fetch the token information like the name, the symbol, and the image, and also the token price. What we had there then was a sync button, and if we click that, it would sync the price of that token. And we could also buy the token by clicking on the buy button. Now this logic is still there, and as you can see, it still buys that same token. Now what we added is the WebSocket connection, and the WebSocket connection and gRPC connection we looked at in the previous video, so that we now also implemented within this tool. So we could start this WebSocket connection, and in the background it will now look for tokens that are being created on the pump fund program. Now we can also stop that WebSocket connection, and then it will stop looking for these newly created tokens. We also added an additional buy setting, and within this buy setting we can enable auto buy via WebSocket. And if we enable this, tokens found via the WebSocket connection will automatically be swapped using the Jupyter V6 swap API, and we will use the same functionality as we had before once we clicked on the buy button. Now the main difference is that we will also store the tracked tokens, the purchased tokens, and our buy settings within JSON files within our project. We are no longer using the actual browser storage, and that is because we also need to be able to access the data from our server components. Since we are using these JSON files within our project to store the data, this data is now persistent. So if we refresh our page, you can see that the tokens are still here. In our previous implementation, they were lost because they were not tracked. Only the purchased tokens were tracked. Now we have consistent storage for also the tracked tokens. And because we have that, we also created buttons here on the right where we can remove these tracked tokens. As you can see, while we purchased a token, we also now have the cost per token here that is being displayed. And we have the remove button again for the same purpose, to remove this token from our purchased token list if it would be sold outside of our app. And we can also choose to sell the token here within our app now using this sell button here. And if we do that, it will sell the token for us and it will remove it. So these are the major changes from the token swapper compared to the token trader. And with that said, let's now have a look at our code base and see how these changes are implemented. Alright, so as we are now going to use a WebSocket as well, the first change that we will do is add a WebSocket URL or a value within our environment file. As you can see, we already had the RPC URL here, and now we will add the RPC URL for our WebSocket as well. And then later on in our WebSocket implementation, we can reference this environment file, pull out the URL, and then use it when we create our WebSocket instance. So the next thing that we will do is create these data files that we will use to store in our buy settings, our tracked and our purchased tokens. And for that I created a folder called data, and within this folder I created 3 files. One called buy settings, and this holds some default buy settings. And you can already see that we have one additional value called WebSocket auto buy, but we will come back to that later. And then we have 2 other files, one called token purchases.json and one called tracked tokens.json. And these files will take care of our storage for our tokens once they are tracked and once they are purchased, and also our buy settings. So we no longer use the storage within our browser, but we are going to fully rely on these 3 files to make sure that we have persistent data within our application. And the benefit is that also our server components will be able to access these files, which was much harder to do so if we had everything stored within our local browser storage. Alright, so if we have a quick look at our application, then you can see under the buy settings that we also have an additional setting there now called enable auto buy via WebSocket. And again, once this setting is enabled, it will automatically swap the tokens once they are discovered via our WebSocket connection. So in order to add this setting, we will have to update our dialog, and this dialog we can find under the components. If we go back to our code under components, we have the buy settings dialog here. First change that we did is once we pull in these settings, which we pull in now via a new function called get buy settings from file, but we will look at that in a minute. we now have this additional value here now called WebSocket auto buy. So we make sure that that is set, or otherwise we set that to false. And also, besides that, we have an additional input called WebSocket auto buy. And this is just a checkbox that we set based on the state that we got back. Now the state is set in the form state. And if it is checked, this is true, and otherwise this is false. If the check is changed, then we will also set a new form state by spreading the current form state and updating the WebSocket auto buy. And we set it to checked as a boolean, as it is true or false. If we save the changes, of course, then we also have to send that updated value to our settings. And we do that by updating the settings object. And of course, you will have to update the buy settings type. In the buy settings type, you will have to add the WebSocket auto buy value here. And of course, it is a boolean, and that is what we specify here. So back to our dialog, what we do here is set the form state for the WebSocket auto buy. And then we store that in the settings that we in turn again send to our buy settings file. Also, this was stored in the browser settings before, but now we are using a new function called save by settings to file. And if we have a look at that save by settings to file, then you will see that we have that function declared here now. And again, we are no longer storing it in the browser storage, but we will store it within the buy settings file over here. And if you have a look at that function, the first thing that we will do is make sure that the directory exists. And for that, we have a function here on top that will just verify if the path where these files are stored are there. If we go back, if that is the case, then it will write this file or these settings that we returned to it into that file called settings file path, and that references to the buy settings.json file. And if nothing goes wrong, it will just silently return, and otherwise it will throw an error. Now also, to get the actual buy settings from the file, we check again if the file directory is there, and if it is not there, we will return the default settings just as we did before, and the default settings are also stored here within the default settings constant. However, if that file exists, then we will take the data from that file and we will return it to the user in the type of buy settings. And then again, if we go back to the dialog, you will see that we can save it using the save by settings to file function. And also here, when we use effect get these file settings from the file using the get by settings from file. So these are the changes needed to make sure that our dialog now has that option to enable the auto buy, and also to make sure that we can save and get these settings from the files. So if we go to our app once again, then you will also see that we now have that button there that says Start WebSocket Connection. And that will actually create and initialize the WebSocket connection for us, and also subscribe to the data stream. And then it will start returning these tokens here within our application. And we can also stop it, and then it will close the WebSocket connection and clean it up for us. Now, if we go back to our code, that logic that you can find under the WebSocket service.ts. And most of this logic we covered in our previous video where we talked about the gRPC streaming and WebSocket implementations. So if you want to know more about that in detail, I suggest that you check out that video, and then you can go back to this video to see how we did the actual implementation. But real quick, I will cover what it actually does and how we make this work within our application. So of course we import everything here on top, and we will need the WebSocket library which comes with the WS, and we import our .env, which also includes our WebSocket URL now. And the WebSocket URL we import here on top together with our RPC URL. And then we specify the program ID and the program log that we want to look for. So we are going to subscribe to the Solana method called log subscribe, and we will look for changes within the pump fun program. And then when a message comes through our WebSocket, we will look for a specific instruction called program log instruction initialize mint2. We also have the wrapped sol here that we will use later on to extract the mint using the token balances from the parsed transaction details. And if that doesn't make sense to you, again, check out the previous video where we cover this in depth. Now, the first function that is important for us is the start WebSocket connection. And what that will do is check if we have a valid WebSocket URL, and also check if it is already connected and if we have a global WebSocket client already. If that is the case, that means that it is connected and already set up, and we will just return true. if we don't have an existing connection, then we want to make sure that everything within this global WebSocket client is actually closed, so that we don't end up with lingering WebSocket connections. So that's what we do here, or at least try to do. And the next thing that we will do is create a new WebSocket instance using our WebSocket URL. And once that instance is created, we will store it within the global WebSocket client. The next thing that we will do is get our subscribe message, and that we will store in the W request constant. And this message constant is stored and returned via the function return subscribe request. So if we look at that, you can see this represents the subscribe object that will be returned to us, and it has the log subscribe method here. And the mentions that we will look for are the program IDs, again, that we import here on top. And the commitment level we set to processed. So that will return to us that subscribe request, which we store in the W request constant. And next we will try to set up our WebSocket listeners. And the first one that we set up is the message one. So if a new message comes through, we will handle it with the handle WebSocket data function. Next, what we will do is when the WebSocket opens, we want to listen for that and make sure that we subscribe to our method. And again, we do that by taking our global WebSocket client and send the subscribe message. Next, we also have a WebSocket listener for the close and the error event. So once that happens, we will also set the is connected to false. Once the WebSocket listeners are set, then we will also try to create an RPC connection, because this RPC connection we will later need to actually fetch the parsed transaction details once we got the signature from the log subscribe method that has been returned to us. Now, once that log contains a log that we are looking for, we are going to take that signature, and based on that signature we can get the actual transaction details that we need to export the mint. Now, if everything goes well, then we will just return a success message. And with this function, we will make sure that we can start the WebSocket listener from within our dashboard. We also have a stop WebSocket connection. That is, of course, used to stop the WebSocket client. And what we do here is try to just close that WebSocket client and make sure that these global variables, global WebSocket client and is connected, are set to false and set to null. And once again here, if everything goes well, we will return success. Now, besides that, we have a function called getWebSocketStatus. This will just return the actual status if the WebSocket is connected and if we have a valid global WebSocket client. Because later on in our app, we will poll on an interval for that status to make sure that our WebSocket is still up and running. Because if something goes wrong, if it is closed for some reason, we want to make sure that our button to start the WebSocket connection reflects that state. Now, besides the functions to start, stop, and get the actual status, we also have the handle WebSocket data function. This function is used once a message comes through our WebSocket to extract the actual mint from the token based on the logs and the signature that was returned to us. Once that message comes through, we will check if it is a valid WebSocket message, and if so, we will extract the log messages and the signature. And then we are going to verify that these log messages actually include the instruction that we are looking for. In this case, program log instruction initialize mint2. And if that's not the case, then we will return and do nothing. But if that is the case, then we will check if our current RPC connection is still alive. Use that RPC connection to get the parsed transaction details based on that returned signature. And then within these transaction details, we are going to look for the meta, because the meta contains the pre and post token balances. And based on these token balances, we can extract the mint from that newly created token in this case. And once we have the mint, we will get our settings from our buy settings from file function. And if auto buy is enabled, then we will also try to swap that token based on the mint that we found. And if that swap was successful, then we will also store that token within the purchased token file. So this is our WebSocket implementation. Again, I covered this really quick as we covered this in detail within the previous video. So if you want to know more about that or about the gRPC streaming alternative, again, I suggest you check out the previous video. I'll make sure it is linked in the description. Alright, so next we can have a quick look at our storage service.ts file. We looked at the buy settings functions here earlier to save the buy settings to a file and also to get the buy settings from a file. Now, as we are no longer using our local browser storage, as I said, we are going to store everything within these files here within the data folder, and therefore we also created the functions that we will use to do so. And these are similar to the functions that we used to save the buy settings, and we also have that now for our token purchases and our tracked tokens. As you can see, we have a function for saving the purchased tokens, and we have a function to get the purchased tokens and also to remove the purchased tokens. As you saw in our application, we have these buttons there now, and we will do the same for the tracked tokens. We can save the tracked tokens to the file, get the tracked tokens from the file, and also update the tracked tokens. As you know, we also have these sync functions, which we can use to fetch the new prices, and this function update tracked tokens in file we will then use to save these new prices within that file. And again, we can also remove these tracked tokens from our dashboard, and for that we use this remove tracked token from file. Now, these functions have a similar approach as our buy settings. For example, to store the token purchases, what we will do is make sure that this folder exists, and then we will take the purchased tokens via the get purchases from file, and then we will use the unshift method to save that new purchase within the purchases object, and then we will store this new object within that file that references the purchase file path, and purchase file path points to the token purchase.json. Again, if you look at the get token purchases from file, what that will do is of course check if that directory exists, and if it doesn't exist, it will return an empty array. However, if it exists, then we will store that into the data constant based on that purchases file path, which again points to that file token purchases.json, and then we will return it to the user as a token purchase array. Now we take a similar approach for the tracked tokens. So again, you can check that logic within the stored services TS file. And the main takeaway is that we no longer use our local browser storage, but we now store all our details like the buy settings, the tracked tokens, and the purchase tokens within these files here under data. Alright, so if we go back to our app real quick, then you'll see after we bought a token, so let's buy this token real quick, that we also have this sell button here now. So if we click that sell button, then it will sell the token for us using the Jupyter V6 swap API, the same logic as we have to buy the token. And once it is sold, it will remove that token. So let's have a look where we add that sell button and what function it triggers. So back in our code, what we have to do is go to the page file. And then if we scroll down, you will see that we return all the elements here. And if you remember, in our purchased token overview, we already had that button to remove a token if it was sold outside our application. We now added a button that says sell, and it triggers a sell function, and what we provide there is the actual token, the token transaction, and also the token amount. So if we look at that function, it is specified here on top. And what that will do, of course, is the same approach as with the buy token. It will set the failed purchase error message to null. Then it will fetch the buy settings. And of course, as you can see here, now we use the buy settings from file. And then we will try to swap that token. But this time we are going to use a unswap token function, and we can also look at that. Now the unswap token function is specified in the token service.ts file. Now the swap token and unswap token function, they are quite similar. The only difference is that we will also get the actual amount of tokens here, and that we will need because we now have to swap all the amount of tokens that we have back into Sol. And to do that, we take the same approach as with our swap function, but the only change is that the output mint now is our Solana mint, and the input mint is our actual token. And the amount is not the 0.01 Sol, but it is the amount of tokens that we hold for this token. And besides that, all the other logic is exactly the same. We will take the same approach, and if the swap is successful, then again we will also return the exact same information, that it was successful, the signature, the token mint, the amount, of course, and the time it took. And then we will return that back to our sell token function here. And if it was swapped successfully or unswapped successfully, we will remove that token from our table using the remove token purchase from file. And we just looked at this function that will take care for us of removing that token from the token purchases JSON file. Now finally, we also added some use states that we use to manage and track the actual connection status of our WebSocket. We also added the use effect to make sure that we can track the purchased tokens within our files. And when this component mounts, of course, we will get these purchased tokens. And we will also set an interval to fetch these purchased tokens. We will also do the same for the tracked tokens. So when this component mounts, we will get the tracked tokens and set an interval for tracking these tokens. And we will also do the same for the WebSocket connection to check at an interval if the WebSocket connection is still up and running. And if not, then we will make sure that our button to start and stop the WebSocket connection actually reflects that state. Now, furthermore, under the add token, sync tokens and sync token function, we need to make sure that we also save these tokens now into the files using their respective functions. And of course, we will do the same as I said earlier. Once we sync these tokens, we also need to update these tokens within their files. And also for that, we have a function called update tracked token in file. Now, if you scroll down, you will see that we also have the functionalities here for starting the WebSocket and stopping the WebSocket, and of course also for removing these tracked tokens. Again, for removing the tracked tokens, we use the remove tracked token from file function that we looked at earlier. And for handling the start of the WebSocket connections, we have the use states that I showed you earlier. And then we also have the start WebSocket connection function to start the WebSocket connection and the stop WebSocket connection to stop the WebSocket connection. So this was a quick review to update the token swapper to a simple trading bot. Now again, all the code is available via our GitHub repository. So if you don't want to type all this logic yourself, you can just pull that repository and look at the exact code base, which we are looking at now. Alright, so now that our app is updated, we are ready to deploy it on our VPS. And in order to do that, we just have to connect to our VPS using SSH. Now once connected, we need to make sure that Node is installed. As our app is built in Next.js, we need Node to make sure that it runs smoothly. Now in order to do that, you can just run this curl command using these flags to make sure it runs silently and also fails silently, specifying this node source URL pipe sudo -e --. And this will install these repositories that we then can use to install npm and node. Now, once ready, you can type sudo apt install node.js -y. And once this is ready, you can type node -v, and then you will see the latest node version here. And you can also type npm -v. And then you'll see the latest npm version here. Now, once you have Node and npm installed on your VPS, you need to make sure that you get your application onto that system. Now, there's a few ways that you can do that. You can, for example, install Git and then pull that repository on your system and install it that way. But for the purpose of this video, we are going to copy the files straight from our local machine into our VPS using SCP. Now, in order to do that, you can just open a new PowerShell window, and then you can navigate to the folder where your SVS token trader folder is located. And you can type the following comment, scp-r for recursive. Then you specify the folder that holds your token trader files, and then you just point where you want to copy it. In this case, we want to copy it to our remote machine or our VPS. However, we are going to do that using SSH, and you can do that by providing the username, which is vibes at the remote IP, and then we need to specify where on that VPS we want to drop these files. And in this case, we say we want to drop these files in home/vibes. And if you then press enter, what you will have to do is provide your passphrase once again. And once you have provided this passphrase, it will start copying all these files onto that VPS. Now, once this is ready, you can switch back to your VPS and then you can check which folder you are in. And as you can see, we are in the home/vibes folder. So if everything went well, we should see now that folder with our application files. So if we type ls, you can see that we now see the folder SVS token trader. So if we change into that directory by typing cd and then the folder name, then we can list all the files typing the ls command. And now you can see that we copied the whole application from our local machine onto this VPS. Now the next thing that we need to do is of course type npm I to install all the dependencies and packages needed to make sure our Next.js application can run. Now once all these packages are installed, you will get a similar message. And what you can do now is type npm run build, and this will create an optimized production build that you then can run on your VPS. Now once that optimized production build is created, you will see a message like this. And the next thing what is left is just starting up our application, and that you can do by typing npm run start. And this will start our application, and it will also tell you that your app is now available via localhost 3000. However, if you want to access this app, you will need to access it via the IP of your server port 3000. Now, if you go to your IP address of your server port 3000, you will see that it is of course not available yet. And that is because, as I told you before, once the VPS is created, it is completely closed down. We will have to add these firewall rules to make sure that traffic can go in and out. And we did that earlier when we allowed the SSH traffic into our system. And now we will have to create a rule to make sure that the port 3000 is available for certain users. Now, how we can do that is, again, you have to go to firewall on your VPS, and then you have to click on add new rule. And here we will have to set accept, and the protocol that we want to accept is TCP. The destination port in this case is 3000. And of course, I believe it's better to also set our public IP as the source. Now, if you want to make this app available for everyone on the web, you can leave this empty. But as we are the only ones that will use this app, I think it's good security practice to provide our own public IP here. If we now click submit and you go back to our application running on port 3000 and you refresh that page, you will see that our app is now available on the public IP of our VPS port 3000. Alright, so now that our app runs on our VPS, let's check out if all the functions still work as they should. So we can start with importing the tokens that we had before, and we can do that by adding the token address and then click the add button. And as you can see, it still fetches the name, the symbol and the image. Let's also try to add that second token, and also here it fetches the name, the symbol and the image. And our sync buttons still work for syncing the actual price and also if the name or the image would be updated. And what we can do next is also try to buy these tokens. So we can do that by clicking on the buy token. As you can see, it buys a token in under half of a second. And that is because all our VPS infrastructure is located within the same data center room as our RPC endpoints. This means we are in full control of the network traffic, ensuring that we have minimum latency. Now, if we refresh our window, you will see that both the tracked tokens and bought tokens are still there, as we're using now these JSON files to store our tokens, and our storage is now persistent. The next thing that we can try to do is enable our WebSocket, and we can go to our buy settings to make sure that our auto buy is disabled for now. And if we save this and start our WebSocket, then the tokens that are being found should show up within our tracked tokens. And you can see that it goes really quickly because often it has no time enough yet to fetch the actual image, but that is fine because we have these sync buttons here on the right. And as you can see now, we have the actual image, the name and the symbol. Besides that, we also have now our remove buttons, so we can also remove these tokens from our storage, and if we refresh, you will see that these are removed. And good to know is that our WebSocket keeps running while we refresh our app, because also that runs in the background on our VPS, and our application is aware of the state of our WebSocket. Again, if we stop our WebSocket now, then we can remove, sync, or buy this token as well. And if we first sync it, then you will see that it updates all the information, and after that we can just remove it. Now the next thing that we can do is enable the auto buy, and if we set this on, it will no longer add the tokens to our tracked list, but it will automatically buy these tokens for us. So if we once again start our WebSocket connection, you will see that they are not ending up in this table, but will automatically be bought for us. And then after that we can try to sell them once again. And as you can see, once these tokens are now being discovered via our WebSocket, meaning being created on pump.fun, they are automatically bought for us. And also here you can see that they are bought within record speed, and that is because, as I mentioned before, our VPS infrastructure is located within that same data center as our RPC endpoints, and that allows us to have a minimum latency and these ultra fast landing times. So let's stop our WebSocket and check our wallet real quick, and here you can see that we actually own the tokens that we bought automatically. And after that, if we want to keep some of these tokens, we can do so. However, if we want to sell them, we can just click the sell button and it will sell it automatically for us, and also make sure that it will be removed from that list. Alright, so we now turned our token swapper into an actual simple trading bot that we can use to buy and sell tokens, and we can even turn on our WebSocket to make it swap tokens for us, which we can later then sell whenever we want. We were also successful in deploying our application on our VPS and make sure that we could both remote login and access our app via port 3000. Now besides that, we were able to install Node, copy our application, create a production build, and start it without any hassle. And we even noticed that buying and swapping tokens was even faster because it was all routed internally. We also saw how we could create our own SSH key pairs and securely connect to our own VPS by making sure that we add our own public IP within the firewall rule. Now this, in combination with all the previous video, should allow you to start building your own application, purchase a VPS, deploy it, and start sniping tokens. Again, you can find more information on docs.solanavibestation.com, and if you think this series was interesting, like the video, subscribe to the channel, and I hope to see you in the next one.